What if we told you that the liquid running through your veins right now is older than civilization itself? That your blood type isn't just a medical label, it's an evolutionary fingerprint left by thousands of years of survival, disease, and adaptation. We're talking about 2.4 million years of history written on the surface of the 25 trillion tiny cells in your body right now. There are 8 major blood types, and each one tells a different story about how your ancestors survived plagues, famines, and migrations across continents. Let's meet them. O positive, the workhorse. 4 out of every 10 people on Earth have O positive blood. If blood types were a democracy, O positive would win every election. Here's the evolutionary twist. O positive blood likely evolved to fight malaria. The absence of A and B antigens makes it harder for the malaria parasite to latch onto red blood cells. The malaria parasite, Plasmodium falciparum, needs to cling to red blood cells to multiply. Crucially, studies have shown this parasite often uses the A and B antigens on the cell surface as anchors to securely attach itself and avoid immune detection. O-positive blood lacks these specific sugar molecules entirely. This leaves the parasite with no good handhold, making the O-positive cells slippery targets. It's like trying to climb a sheer cliff face with no gear. While O-positive people can still contract malaria, the infection is often less severe and less likely to progress to fatal cerebral malaria. This slight genetic edge means the difference between life and death for millions of people across malarial belts like Africa and Southeast Asia, cementing O-positive as the dominant type. The trade-off: O-positive blood is more vulnerable to cholera and norovirus. Evolution doesn't give you superpowers for free. It gives you trade-offs. A-positive, the farmer's legacy. A-positive tells a story about the invention of agriculture. When humans stopped hunting and started farming about 10,000 years ago, we lived in dense communities and touched the same tools. Bacterial infections spread like wildfire. The A antigen, a sugar molecule on the surface of red blood cells, may have provided a stronger immune response against these bacterial invaders. In crowded farming villages, A-positive blood became an evolutionary advantage. But evolution is never that simple. A-positive blood is associated with higher risks of blood clots, heart disease, and certain cancers. The same trait that helped your ancestors survive dysentery might increase your risk of a stroke today. Why the increased risk of clotting? The A antigen molecule is remarkably similar to a key clotting factor in the body called von Willebrand factor. Having this A-like sugar constantly present seems to lead to slightly higher baseline levels of clotting proteins. In the environment of a crowded farming village, where a wound could easily get infected and lead to fatal sepsis, a faster, more aggressive clotting response was a huge survival bonus. It stopped bleeding fast. However, in the modern world of processed foods and sedentary lifestyles, that same hypervigilance leads to small, unwanted clots that cause strokes and heart disease. The powerful, adaptive immune system of the farmer's ancestor is now slightly over-optimized for a life that no longer exists. Trade-offs. Always trade-offs. B positive, the nomad. B positive is less common globally, but travel to Central Asia or the Middle East and you'll find it everywhere. This is the blood type of migration. Some researchers believe it evolved among nomadic populations who herded livestock, drank fermented milk, and faced different diseases than farmers. Studies suggest B-positive blood processes carbohydrates and fats differently than other types. It's like your metabolism got fine-tuned for a lifestyle that no longer exists. This isn't just theory. Researchers believe the B antigen may have co-evolved alongside a unique gut microbiome suited to the nomadic diet. Think heavy, fermented dairy products like yogurt, kefir, and even mare's milk, combined with occasional meat and very seasonal vegetables. The B antigen is chemically similar to certain sugar molecules found on the cell walls of beneficial bacteria within the gut. This similarity may have fostered a stable, protective environment, giving B-positive nomads a highly efficient system for extracting calories and nutrients from a wide, unpredictable dietary range. Today, that metabolic uniqueness is less vital, but it's a living testament to the survival of a people who mastered the ability to thrive where others starved. The trade-off? B-positive blood is rarer in blood banks, which means if you need a transfusion, finding a match can be harder. AB positive, the modern hybrid. AB positive is rare. It's the youngest blood type, only appearing after populations with A and B blood start mixing, probably within the last 1,000 years. It's the biological proof that humans have always been migrants, travelers, and, let's be honest, romantics who fell in love across tribal lines. Medically, you are the universal recipient. If you have AB positive blood, you can receive from anyone. You're the ultimate acceptor. The trade-off? AB positive blood is so rare that you can almost never donate red cells to anyone except other AB positives. You're universally compatible as a receiver, but nearly useless as a red cell donor. So far so good. Simple antigens and a neat history. But buckle up, because this is where the story gets evolutionarily strange. There's another layer, the Rh factor. It's a protein that either exists on your red blood cells or doesn't. If you don't have this protein, you're Rh negative. And being Rh negative, that's where things get weird. O negative, the universal savior. O negative is so rare that hospitals treat it like gold. Why? Because it's the blank slate of blood. No antigens, no Rh protein. If there's no time to test a patient, O negative saves lives. But here's the problem. O negative people can only receive O negative blood. If you need a transfusion, you're hoping the blood bank isn't empty. Evolutionarily, O negative is a mystery. Why would losing the Rh protein be advantageous? Some researchers think it might provide resistance to certain parasites. Others think it's just a genetic drift, a random mutation that stuck around. Either way, if you're O negative, you're medically priceless and evolutionarily puzzling. A negative, the immune warrior. A negative comes with a hidden danger, pregnancy complications. If an A negative mother carries an Rh positive baby, her immune system might see the baby's Rh protein as a foreign invader and attack it. This is called hemolytic disease of the newborn, and before modern medicine, it killed countless babies. Today, we have treatments, but evolutionarily, A negative pregnancy was a genetic gamble. B negative, the forgotten type. B negative is one of the rarest blood types, found in less than 2% of people globally. It's so rare that most blood banks barely keep it in stock. If you're B negative, you need B negative or O negative blood. That's it. 2 choices. Evolutionarily, B negative's rarity suggests it faced strong selective pressures. Maybe it was advantageous in specific environments. Maybe it was just unlucky. What we do know is that B negative means you're part of a very exclusive, very medically complicated club. AB negative, the unicorn. And then there's AB negative, the absolute rarest of the 8 major blood types. Less than 1% of humanity has it. If blood types were Pokemon, AB negative would be a shiny legendary that you only encounter once in a lifetime. Medically, AB negative red cells are almost useless for donations. They can only go to other AB negatives, who barely exist. But here's the twist. AB negative plasma is liquid gold. It can be given to anyone. So, we've climbed the ladder. But here's the thing. Blood types aren't a hierarchy. They're an ecosystem. O negative saves lives in emergencies. AB positive receives from everyone. A and B types fight specific diseases. Every blood type exists because it solved a problem somewhere, sometime, for someone's ancestors. Remove any one blood type, and the system gets weaker. We don't need more O negatives or fewer AB positives. We need all of them, in the balance that evolution left us. So if you've ever wondered what your blood type says about you, here's the answer. It's proof that your ancestors faced diseases you'll never see, survived disasters you can't imagine, and passed something incredible down to you. You are here, and your blood type is why.